Hello, today we're going to learn about classes. In computer science, a compound data type refers to a data type that can be created by combining primitive data types or other compound data types. You may feel unfamiliar with the word primitive data type, a data type that is provided by default. For example, we can think of built-in data types as primitive data types. Until now, we have learned types such as int, bool, string, and float, and these types are all primitive data types. In Python, users can create their own compound data types. In Python, it is called class, and a class can be created through the keyword class. Creating a class means creating a new type. So after defining a class, we can create new values or variables of the class. Try running the following program. First, after the keyword class, write a new data type rectangle and a colon, and then below it and create two attributes called width and height. Then the type rectangle is called in the form of function assigned to a variable a. Here, rectangle is a type created with the class keyword, and a is an instance of rectangle type. Instance is a variable belonging to a specific class type. For example, the code in the previous slide means that we have created an instance A of the rectangle class. To help you understand the terms class and instance, let's use an analogy. If you think of a class as a blueprint for a house, instances can be thought of as actual houses built from that blueprint. Attribute is a variable that exists as a member inside a class. For example, rectangle class shown in the slide has attributes called width and height. The attribute of the class can be accessed using dot. For example, when A is an instance of rectangle class, we can access the attribute width of A through the code a.width. Unlike string type, the value of attributes of a class can be changed. For example, if a new value is assigned to an attribute of an instance, the value of that attribute is changed. When there is an instance called A with the initial width attribute value of 1, after the program in the slide is executed, the width attribute value of A is changed to 3, and the value of height is changed to 4. Python provides a method called initializer to initialize internal attributes when creating a class instance. To use it, we first need to define the function called init as shown in the slide. You can create a class instance without defining an initializer function, but through an initializer, a programmer can initialize and configure the internal attributes of any instance. Note that the parameter itself must be written in the initializer function so that the attributes inside the instance can be handled within the initializer method. Let's look at an example using initializer. Take a look at the following program and check the values displayed on the screen when you run the program. When you execute the program, a class called rectangle is defined. In the initializer, width and height attributes are initialized to 0. And A is created as a rectangle instance. At this time, rectangle calls the init method. Therefore, width and height attributes in instance A are initialized to 0. The initializer can also receive external arguments. When creating a class instance, if you want to set the initial value of the attributes inside the class instance, we can pass arguments to the initializer. For example, if you want to set the initial attribute values of the rectangle class you made earlier, define width and height as parameters after the self parameter. Afterwards, when an instance is created and the arguments are passed, the values passed to the parameter are again assigned to the self.width and self.height attributes. For example, when creating an instance called A, if you pass 1 and 2 as arguments, the arguments are assigned to the parameters after self. Therefore, in instance A, 1 is stored in the width attribute and 2 is stored in the height attribute. We just learned that initializer is used to initialize internal attributes. However, if you want a class instance to be initialized even when the user does not provide any attribute values, you can set a default argument. For example, in the case of the initializer shown in the previous slide, if you do not set the width and height arguments when creating a class instance, an error occurs and the class instance cannot be created. However, for example, if you set the default argument values of the parameters shown in the slide, you can create class instances even if no arguments are passed when an instance is created. In the previous lecture, we already learned about methods. Like in list and string, a function that exists in a class is also a method. For example, the initializer function we just saw is also a method. Let's define our own method. In the previous slide, we learned that we can access the attributes of any class using dot. Likewise, any method inside any class can be called using a dot. First, self must be added as a parameter in any method, and additional parameters can be defined. After that, when a certain class instance is created, you can call methods in instance.method parentheses format. For example, in the class rectangle shown in the slide, a parameter called newWidth exists in the method called setWidth. Therefore, after creating instance A, if you call the setWidth method with 3 as an argument, the width attribute of instance A is changed to 3. A function can receive a class instance as an argument, and since the class method is also a function, any class method can receive another class instance as an argument. For example, the method called compare is a function to find out which of two rectangles has the larger area. In the code shown in the slide, we implemented a method by taking another rectangle class instance as an argument. So when the code shown in the slide is executed, instance A has smaller area than instance B. So when the line 19 is executed, -1 is printed. When line 20 is executed, 1 is printed. As we saw earlier in Python, you can change the value of the attribute of a class. Therefore, a class is a mutable type. For example, consider the following code. Let's say you have a basket class. Inside it, there is an attribute called apple. When we call give method, we can change the apple attribute of other basket. For example, when the apple attribute value is 5 for the basket instance A, and the apple attribute value is 1 for the basket instance B, after calling the give method of A instance as shown in the slide, the apple attribute value of A becomes 3. B will have the apple attribute value of 3. Let's practice how to use class. First, let's create a class called NPC. For example, when creating a class called NPC, you will be able to create attributes such as age, health point, and mana inside. Let's create attributes name, HP, and mana in the NPC class. After declaring the class, let's create 2 NPC instances. Since the initializer is also a function, you can create optional parameters like any other function. When NPC is assigned to the NPC3, name attribute will have the value of unnamed, and HP attribute value of 100, and mana value of 100 will be stored in NPC3. If NPC is assigned to NPC4, NPC4 becomes an instance with name attribute value of unnamed, HP attribute value of 100, and mana value of 20. NPC5 becomes an instance with a name attribute value of Kate, HP attribute value of 100, and mana value of 100. Let's implement another method. The introduce method is a function that prints name attribute value. For example, when there is an NPC instance, NPC1 with the name attribute of Barbara, if you call NPC1.introduce, you can see the string as shown in the slide. Let's add new methods to the NPC class we've made so far. Try implementing the 2 methods shown in the slide yourself. The first one is a method called takeHPPotion, which increases the HP attribute of an NPC instance by 50. And the second method is called takeManaPotion, that increases the mana attribute of an NPC instance by 40. And the maximum HP and mana are 100, and the minimum HP and mana are 0. Pause the lecture video and continue playing after implementing the methods on your own. For example, we could implement a function like this. TakeAPPotion method is implemented by using if-else statement. When we increase HP by 50, if the HP attribute already exceeds 100, it assigns 100 to self.hp. Otherwise increases self.hp by 50. In the takeManaPotion method, when mana is increased by 40, if it exceeds 100, 100 is assigned to self.mana, and if not, self.mana is increased by 40. Let's check whether these methods work well by calling them. Let's create NPC1 and call 3 methods. If NPC1's method takeHPPotion is called, the initial HP attribute value is 47, so it is increased to 97. And the initial value of the mana attribute is 79, so it is changed to 100 after calling takeManaPotion method. If you print attributes of NPC1 after calling the methods, you can see that all the methods are implemented as expected. In the previous lecture, we learned that lists can also be printed via the print function. Similarly, let's print the class instance by passing the class instance as an argument to the print function. But when you look at the printed result, it is hard to understand the content of the class instance. What should we do to print the values inside the class so that we can see the contents of the class instance? In Python, you can create a method called stringSelf in any class, just like an initializer. The stringSelf method is a function that returns a string value of a class instance. If you define this function, you can print the class or cast it to a string. For example, in order to print the attributes of NPC class recognizably, we can define the stringSelf method as follows. The string method can be freely defined as you want, so you can implement it differently. However, the type of the return value of the string method must always be string type, so you need to implement the function correctly to avoid errors. If you run the program, you can print the MPC class instance in a recognizable form. In addition, after we define the string method, we can cast the class instance to string. In Python, there is a type called nonType in addition to the various types, data structures, and classes that we have learned so far. Nontype is a type that has only one value, none. For example, functions without a return value return the value of none. Since the none value is not a string, it is used without quotation marks. For example, if we enter the code shown in the slide into the Python shell, we can know that the value none is the value of nonType. Let's look at an example where nonType is returned. Let's run the program on the side and check the result. If you run the program shown in the previous slide, the following result is printed. First, print hello is called to return the value to a variable a. And in the first line of this function, hello is printed. Then, the keyword return is executed. We learned that if there is a value after return, the function will return some value to the point where the function was called. But the function didn't return anything, so nothing is assigned to a. And if you print a, you can see that the value none is stored in a. In other words, none can be seen as a value expressing an empty state. Even if there is no return code, the print hello function exists without returning anything. So in that case, a will also have the value none. There are not many cases where we intentionally assign a value of none. Usually, when creating a large program, variables with the value of none are created during program execution due to a bug, and variables with non-value often cause problems in programs. When programming or debugging in the future, please take a good look at the return value of the function and the value of the variable. Before we move on to the exercise, I want to give you some additional knowledge that will help your coding. VS Code provides various shortcuts to making code easier. You can learn how to use these shortcuts at the link below. Let's take a look at keyboard shortcuts that can be useful when using VS Code in Linux. These shortcuts work the same on Windows. First, Ctrl-X cuts the selected code region. Ctrl-C is used to copy the selected code area. Ctrl-Z undoes the previous editing action, such as cut, erase, write code, paste code, etc. Home moves the current cursor position to the beginning of the line. The End key moves the current cursor position to the end of the line. Control Home moves the current cursor position to the top of the file. Control End moves the current cursor position to the end of the file. Control F is used to find the text in the current file. Control Shift F is used to find specific text in the folder the current file exists, or in all files in the currently open project. Control G is used to jump to a specific line in the currently open file. Control S saves the file you're currently working on. Now, let's solve an exercise problem. Let's implement a method called getPerimeter in the rectangle class we made earlier. Think of the rectangle class as a rectangle and implement a function that returns the value of the perimeter of this rectangle. For example, we can implement the getPerimeter method like this. Since the perimeter of the rectangle is twice the sum of its height and width, we can return this value. This is end of today's lecture. We will learn more about classes in the next lecture.